what is the Micronaut Framework? First of all, is an open source framework. Is licensed under Apache 2, thus no strings attached. It's a modern JVM framework. By that I mean it is already used by many companies in production. So we released the first GA version, the first Micronaut 1.0 back in autumn 2018, and we will be releasing Micronaut 4 in 2023. So it's not new, but it's modern enough that you will see that it's a framework to work in 2023 with the things that you will expect from a framework from the 2020s. That I mean, like cloud first, JSON approach, design from scratch. Basically, most of the people in the initial development team of the framework, we come from the Grails framework, which is a framework that was built on top of Spring Boot. So if you are coming from a Spring Boot, you will see that there is like a smooth learning curve. There are many things great in Spring, and Micronaut doesn't try to reinvent the wheel when those things work. We like to say that Micronaut is a foundation framework. By that I mean that you can build any application, and given that today I am talking to the Kotlin user group, my bet is that many of you will probably have experience building Android applications, and you can use many parts of Micronaut in Android applications. In fact, you can use Micronaut's dependency injection engine within a Micronaut application. You will see that it's an approach similar to Dagger for those of you who have used a dependency injection engine in the Android world. And if you have built Android applications, you probably have used something like Retrofit. You will see that the Micronaut HTTP client will remind you a lot to the Retrofit HTTP client in the sense that this you will basically write an interface and it will be built at build time. So today I'm going to show you like how to write in the demo. I'm going to be writing like a backend application, but you can build any kind of application with Micronaut. You can build monoliths, you can build microservices, you can build serverless functions. As Lee was saying before, you can build command line interface applications. So it is a modularized framework, and depending on the kind of application you want to build, you will use some parts of others. Highly optimized. Micronaut leverage the standard Java annotation processor mechanisms to generate extra bytecode at build time. We will not modify your bytecode, but we will generate extra bytecode that will sit aside your the bytecode of your classes. And we like to say that we like to move as much logic as possible at build time. That's logic such as dependency injection logic, validation logic. Micronaut data will generate pre-compute as much as it can at build time. In general, traditional JVM frameworks have done as much or all of its power has been done at runtime, and Micronaut is done at build time. That what enables the framework to have a fast startup time, which hopefully I will be able to show it to you today, and also like a slow memory consumption. That's important because startup time will be useful not just when you go to production, but also while you are developing locally. And you will see that when you work with Micronaut applications, you will write many more tests and you will write many more functional tests, because the application is so fast to start that you will not shy away from writing functional tests. The framework follows a semantic version. We released a minor version more or less every 6 to 10 weeks, and we released like patch versions weekly, typically, patch versions with bug fixes, minor versions with features, and major versions with breaking changes. So Micronaut 4, for example, we will have a Kotlin 1.8 and major version of Ktor, for example, which is another Kotlin framework integration we have. So yeah, semantic version, we would like to say that we are quite strict about it. So what that brings our users is that the upgrade path is really easy. Upgrading from patch versions or minor versions is typically just changing, if you are using Gradle, your Gradle.properties files, or in Maven, your pom.xml file. When you hear about Micronaut, you will hear like about AOT ahead of time. And basically what we do is we build as much as possible at build time, as I was saying. So dependency injection, configuration injection, annotation metadata, AOP. AOP is logic that you will see, for example, for validation or for transaction demarcations. Being introspections, we are able to basically serialize and deserialize from JSON without using any reflection. So in general, we avoid reflection like it is the plague. There is no like dynamic class loading, no class path scanning, no proxy generation. So we moved as much as possible to build time. In terms of what the framework does, we have dependency injection. We comply to the JSR 330, so you will use the standard Jakarta annotations for injecting or at singleton, etc. You can define configuration as you are used to in other frameworks. You can define configuration with properties files, with YAML, with TOML, and since this is the Kotlin user group, you can use also config for K. Validation support is reflection free. We support a subset of the Beam validation specification. If you want or if you need the full Beam validation specification, you can use Hibernate Validator, which is the reference implementation with Micronaut as well. We support AOP completely compile time and reflection free, and it's actually quite easy to build AOP, your own custom AOP functionality. We have Micronaut has built-in HTTP client, so when you are working with Micronaut, you don't need to have something like Retrofit or Volley or something like that. You will ship with our own HTTP client, which you can use either in a declarative or in a manual way. I will show you in the demo. Language agnostic, we support Java, Kotlin, or Groovy. For Java, we use the standard annotation processors. For Groovy, we use the AST transformations. For Kotlin in Micronaut 3, which is the version, the latest version of Micronaut, in the one that I will be demoing today, we use KAPT to basically hand to the standard Java annotation processor. KAPT is in maintenance mode, and we are working on supporting KSP. And I think we will have KSP support in Micronaut 4. So if you are planning to use Kotlin with Micronaut, you are in good hands. And we have like a vibrant community of Kotlin users. I think like I have not checked lately the stats, but around 1/3 of the applications that are generated in Micronaut Launch, they use Kotlin as the programming language, and you will see in the GitHub activity that we have many users using Kotlin. Which Java versions do we support right now? Micronaut 3 still supports Java 8, so we support Java 8, Java 11, and Java 17, so the latest LTS releases of Java. If you can, my recommendation always use the latest version of Java available to you. I will be showing today, I will be selecting Java 17. Build agnostic, you can build your Micronaut applications with either Gradle or Maven. I assume many of you, since you are like using Kotlin, you probably use Gradle, and I will be showing you Gradle today. We support both the Groovy DSL or the Kotlin DSL. We have build plugins, both Gradle, Micronaut Gradle build plugins maybe build plugin as well. I will be using those. They are not required. As I said, my code is built on top of standards in Java. So Java notation processors are not something that my code invented. They are like a part of Java, and the build plugins that are basically will make your life a little bit easier, but they are not, if for whatever reason you don't want to use them, completely fine. Test framework agnostic, you can use whatever testing frameworks you prefer. We support JUnit 5, we support the Spock framework, we support code test as well. And I will show you today JUnit 5 with Kotlin, because my code test is not very good. But if you want to use code test, we support that. We support in Micro 3, I think we support code test 5 and code test 4. So if you want to use a Kotlin testing framework, that's completely fine and supported. And let me show you a demo. So the home of Micronaut is micronaut.io. So I'm gonna go here to micronaut.io, and we have like you see the launch button here. That's our project generator. We have also like a command line tool that you could use to generate a project. I'm gonna go with Java 17. I'm gonna generate a Micronaut applications. I told you you can generate many kinds of applications. So you could generate like, for example, a pure Kafka consumer, gRPC application, Lambda function. So I'm gonna go with Java 17. I'm gonna say here like Brighton demo. Com.example as the base package is fine. I'm gonna select the latest stable version, so 3.8.1. I'm gonna go with Kotlin as the language. I'm gonna select Gradle Kotlin DSL. I'm gonna go with JUnit. I'm gonna click generate project. This is gonna download a zip file to my computer. I'm gonna unzip it. We have great support in IntelliJ IDEA, which is the IDE that I will be showing you today. But if you prefer to use something like Visual Studio Code, that has a great plugin as well. So I'm gonna drag and drop the project to IntelliJ. Let me show you the project. So this is a Gradle build because I selected Gradle. So we have the standard Gradle W, the wrappers, and the standard Gradle files from a Gradle project, Gradle wrapper.properties and the Gradle proper.jar. We have a settings.gradle in case you want to have like a multi-project build. I just have one module here. And then I have the Kotlin KPT. So whenever you add something, let me make the font bigger so that you are able to see it. Sorry. Hopefully, is the font good enough? If not, please let me know. I have here the window. I have another monitor with the chat open. So whenever you have something on the annotation processor class path, you will have to use the KPT Gradle configuration. Let me just remove a couple of things that will not be used in the demo. And let me show it to you. I'm gonna go. I have just one main class, nothing fancy. In Micronaut, you can run in the application just by clicking the play button here, or just by running the Gradle task run. So let me just do that and show it to you. So we don't have any anything in the application. So the application started in less than a second, included some compilation there. I'm gonna go here and I'm gonna say Gradle. This is my recommendation when you go with that you delegate completely to Gradle. So that's fine. So the first thing that I'm gonna do is I'm gonna come here and create a controller. So let me create a controller. I'm gonna call this the greeting controller. Kotlin class, nothing fancy. How you define routes in a Micronaut application? Well, you create controllers. In the controllers, you're going to define the endpoints. And Micronaut its core is an annotation-based programming model. So you are gonna add annotations to your classes. So I'm gonna annotate this class with how do you create a controller? Well, we have an add controller annotation, as you can imagine. And how do you create like a get endpoint? You have like a get annotation. And then I create a method and I say index. And since Kotlin, one of the nice things of Kotlin that I like is that you can, everything is an expression and you can assign. I can do here like hello world. And I can, my code by default expects that you are working with JSON. So unless you specify otherwise, the content type is going to be JSON. So let me specify a content type of plain text. So I'm going to say this endpoint is going to produce plain text. And I can just run the application. Application will start. I'm going to open here a terminal and I'm going to send a curl request. So I'm going to do curl -I so that we see the HTTP status response. And I'm going to do -N so that we see the response. I'm going to do localhost 8080. And you see here the hello world, hopefully. You see here the hello world being responded by our applications. Let's do something. Let's create how do you specify like a sub route? Let's do here hello. I could be running this with run -E, which will recompile. Let me do here hello. And there you go. So that's how it is, how easy it is to write a controller. Let me write a test for this. And this is coming back to my point of you will write many more tests because tests are fast to run. So I'm going to create a greeting controller test. Be a Kotlin class. I'm going to create a method. This is JUnit, so it's going to be a test. It's going to be a method annotated with a test. It'll be fun because that's how fun Kotlin methods are. I'm going to say test hello. I'm going to say, I'm going to show you how to like run the real application within a test. And then I'm not going to show you an annotation that we have to make this simpler. So let me create a variable called server, and I'm going to call application context run embedded server. I have to do class.java. And that's running the server. And because I am a good citizen, I'm going to close the server at the end of my test. When we created the application, we already have the MyCode HTTP client dependency. So I can use the MyCode HTTP client. So I'm going to create an HTTP client bean. I'm going to go here. I'm going to go application context, create bean of type HTTP client class.java. And I'm going to point the HTTP client to the server URL. And I'm going to assign this to an HTTP client variable, HTTP client. And I'm going to create a blocking HTTP client because by default, the MyCode HTTP client is going to return like reactive string types. So it's going to return publishers. But in my test, I don't care about publishers because I want to see the results now. So I want to block. So I'm going to get a blocking HTTP client. And I'm going to do a request. And let me create a request variable to show it to you. So we have like a fluid API. So I'm going to create a request. We have like verbs for the see. This is me HTTP request string. There you go. So I have a request. The request is like, as you see, there is like a fluid API sending a GET request against the hello endpoint. And now I can do like client. Typically, when you work with an HTTP client markup, you work either with Exchange or with retrieve. You work with Exchange when you want to evaluate the whole HTTP response envelope. You want, for example, to do an assertion in the status of the HTTP response. you work with retrieve when you only care about the body. Let me just care about the body for now. So I'm going to go here request, and I'm going to assign this to a variable called response. And then I could do here an assert equals from JUnit. And I could do this. I expect this to be hello world response. And if I am able to resolve the import assert equals, there you go, like an extra else. So I should be able to run the test. So the test is going to run a real server and hopefully it's green. And this is going to allow me like to evolve in the application. So the test is green. Perfect. Let me show you failing. So if I do hello moon, the test should fail. And it fails. Let me show you something, which is we are like actually doing HTTP requests. This is not a trick, no trick here. So my code uses SLA4J as a login for chat, but by default we use logback. So we have like a logback.xml for configuring the logger in your application. So a standard Java login, and I'm gonna do here. I'm going to configure the Micronaut HTTP client to log in the trace level, and we are going to see the HTTP request hitting the server and the response coming back. So I'm going to go here, make it this big, and you will see here the HTTP request being sent to the server and the response coming back. So this is starting a real server and sending a response. So this is a bit tedious to like start a server and then close it. So Micronaut has an annotation, a Micronaut test, which is applied automatically in your test class path by the Micronaut graded build plugin. It has an annotation that you can use to simplify some of this ceremony. So I'm going to use here at Micronaut test. Now I can inject also the HTTP client. I can inject the HTTP client like this. So you add a late init bar. Basically, you are telling Kotlin like you are not initializing this variable right now, but you are on top of this, and this is going to be initialized later. But the way it works is my code will start an embedded server, and it will basically resolve these injection points once the application context, the dependency injection engine has started. So hence the late init, and this is an annotation that you can tell essentially when you generate the bytecode, where do you want this annotation to be applied to? By using the add client is a Micronaut annotation. You are basically pointing an HTTP client to the root of the embedded server. So now I can get rid of this. I can get rid of this. So the test is a bit more succinct and nice. So let me run the test again. To you. Hopefully it will be still green. So this is what we typically refer to as a manual HTTP client. When you are working with a manual HTTP client, you work either with retrieve or exchange. We could have written, for example, here, but an exchange and get the HTTP response and check that this is a 200 OK. But a nice thing that Micronaut has is it has built-in a declarative HTTP client, and the declarative HTTP client will be generated at build time. So I'm going to come here and do here. I'm going to say greeting client. I am adding it in my test class path, and I'm going to say here this is an sorry, not a Java class, but a Kotlin. I'm going to create a Kotlin interface actually. I'm going to call this greeting client. And I'm going to treat this with that client, and I'm going to treat it with pointed to the root of my application. I'm going to go here and inject it. Let me inject it. I can do inject, late init bar, greeting client. the test should still be green, and this injection endpoint should have been fulfilled. I'm going to create, how do you create methods that send requests from an HTTP client, from a client HTTP client? Really easy. Same way we did with the client, with the server, sorry, but vice versa. So I'm going to come here and I'm going to say this is going to be still like going to be a method that takes a string as the return type, and instead of produce, it's going to consume plain text. So now I can come to my test and I can, you see, it's an interface annotated with that client. You have the different routes that this HTTP client is consuming. They are annotated with HTTP verbs. So I'm showing you the get, but as you can imagine, we have a head, we have a delete, we have a post, we have a patch, and options. So we have like an annotation pair, HTTP verb. We have here like a path. You can combine the value in the client and in the method, or in the controller in the method, and the return type. So here we are like returning a blocking type, but you could return like a publisher as well if you were like writing this in your main class path and you didn't want to block. So in my test, I'm going to do now here the same thing, but instead of using this, I'm going to use the declarative client. So I'm going to use greeting client.index. I call this index, but I could have, let's rename this to something else, like hello. So you don't have to have the method name the same as you name it in the controller. You can name it whatever you want. The method name doesn't matter. So it works. Let me show you that there are actually 2 requests now being sent. This is the request being sent by the manual HTTP client, and this is the request being sent by the declarative HTTP client. So the declarative HTTP clients, you have what we retrofit. They will remind you to that. We have one implementation right now in Micronaut 3, which is built on with Netty. We are working in one implementation with Micronaut 4, which will use the built-in JavaNet HTTP client. So you will be able to use either of. If the built-in Java client suffices you, you will be able to use that as well, and you will not have to change the code. The interface will be the same. I was telling you that Micronaut, as its core, is a dependency injection engine. So let me show you what I mean. We support dependency injection. So I'm going to create an interface. I'm going to say like greeting service, for example. Let me create a pollo. In Kotlin, we have one great thing, which is data classes. So I'm going to create a data class. And I'm going to say this is greeting. In data classes, we by default, we have to specify at least one. So I'm going to specify like message, and this is going to be of type string. The greeting service is going to be an interface that responds a greeting. So it's going to be a fun greeting, for example, greeting. And I'm going to inject it in the controller. How do you inject in the controller? We support several injections. So you can inject as a field, as I showed you in the test with the @inject annotation. You can inject. We support method-based injection, but our preferred way, and one way that really shines in Kotlin, is constructor injection. So I'm going to inject via constructor injection. So I'm going to go here and do a bald greeting service, and that will be enough. And now I can change this to greeting service greeting, and this method is no longer returning like a plain text, but it's going to return this data class that is going to be serialized as JSON. So I'm going to remove the produces. I don't have to specify produces application JSON. That's what Micronaut thinks that you are doing by default. This is part of what I was telling you before, that Micronaut is a modern framework. So by default, Micronaut expects that you are receiving a JSON in the body of your post request that your application is getting, but also that you are producing JSON. So I'm gonna be returning greeting, and I don't have an implementation, so the project is gonna fail. Let me change the test. So instead of hello world, I'm gonna create a variable called expected, and expected is gonna be of type string. In Kotlin, you can use this thing instead of escaping the double quotes. We can use triple quotes and do here like message hello world. So this is my JSON object, and I could now replace this with expected. The test is gonna fail because Micronaut is gonna tell me, Sergio, I don't know how to fulfill this injection point that you told me that I have to do in the greeting controller constructor. So let me run the test and show it to you, the failure. And we will solve the failure in a second. One of the nice things of Micronaut is because we don't have all of that extra runtime proxies, and the errors are quite easy to understand. So it tells no bin of type greeting server exists. Make sure the bin is not disabled by bin requirements. We have like a nice add requires annotations that I'm not going to demo today, but check it out. It's telling you like basically it's not able to fulfill the injection endpoint. So how do we create a singleton in Micronaut? Well, we use the standard Jakarta notation called at singleton, and we do that. So I'm going to create like a greeting service implementation. It's going to be like a class. Let's do implement the interface in Kotlin. By implementing the interface, I'm going to have to override the greeting method, and I'm going to do greeting and Kotlin, no need for a new keyword. So I'm going to do hello world. And I have to annotate the class with at singleton so that Micronaut basically knows that this is a singleton of the bin of type greeting service. So now the injection endpoint will be fulfilled, and hopefully my test will still be green. It's not, and it is because I think I forgot to change the client. So let me change the client. So the first one passed, but the client I forgot to change. So now the client is no longer receiving a string, but is going to be receiving an object. Let me run it again. Okay, still no luck. Okay. It's telling me that the test expectation doesn't matter. And actually, the ID was already hinting that to me, but I didn't listen to the ID. I should listen to the ID more. So it's telling me that this thing is an object and this thing is a string. So what I could do is create here something like message and use another nice feature of Kotlin, which is string interpolation. And now here do message. And now the ID like it more. I am comparing apples to apples. So let me run the test again, and the test should be green now. So the test is green. What did we just do? I created an interface, nothing fancy, a standard interface in Kotlin. I created a class which overrides, implements the interface. And I annotated the class with that singleton. And because of that, I have now a bin of type greeting service. So I have a bin of type greeting service that I can inject in other Micronaut components. And how I'm injecting it, I am using constructor injection. And as you see, I am never instantiating the greeting controller class. Micronaut will instantiate the greeting controller class and will provide the collaborators for me. What did I show you also? By default, Micronaut will use Jackson. We have also a reflection-free. You can use Jackson reflection-free as well by annotating this class with at introspected, and we will generate a build time bin introspection information so that we are able, given like a JSON payload, instantiate this class without using reflection and fill it with the JSON. We also have an even more interesting project called Micronaut Serialization, which is a drop-in replacement for JSON data bind. You have to annotate your classes with observable, and basically that means that you can still use the JSON annotations that you are used to, like JSON property, etc. But under the hood, you have like you are using micro serialization, and that's kind of a bit more secure because you have to whitelist which classes can be serialized and deserialized, and it's also like completely reflection free and a little bit more optimized. So we have dependency injection, construction injection, also field injection that we are doing in the test, and also method injection. We support configuration injection, which is something that you probably expect from a modern framework, and we can have, like, for example, even immutable configuration injection. So let me show that to you. So I'm going to create an interface. I'm going to annotate it with greeting configuration. And I'm going to have a method called get prefix. I'm going to return a string. And I could just have immutable configuration by annotating this class with configuration properties. If you have worked with Spring Boot, you know that there is a configuration properties annotation for this kind of thing. We have the same annotation. As I told you, when the learning curve to learn Micronaut, if you're coming from a Spring or Spring Boot background, is really, really smooth. So I'm going to add here app, and I'm going to do here I can go to application.yaml. So I went with the default configuration format, which is YAML. And now I can do here app, prefix, and I could do here hello. But let me write something else like hola. And let's see the test fail. The app here is not a coincidence that matches the value of add configuration property annotation, and the prefix is not a coincidence that matches as well. So now I can inject this immutable configuration object in my greeting service implementation. So how can I inject it? Constructor injection again. I could do here val greeting configuration, and now I could do here greeting configuration get prefix. Let me just run the test, and hopefully it will fail. And it's telling me that I was expecting hello world, and it's returning hola world. So it is actually getting the value from configuration. So that's great. Let me change this to hello. And let me run it again. So configuration injection. So let's recap what we have done. How do you create routes with Micronaut with controllers? You annotate methods with add get, add post, add path, add put. We have a built-in HTTP client. We support the configuration injection, completely generated at build time. So it's kind of similar to Dagger for those of you. Under developers, we support configuration injection as you are used to. I'm going to show you validation as well. So imagine we were passing here to this method like a parameter called a name of type string. I could say I could use a standard annotations to provide validation. So I can say this name has to be a pattern. Let me see if the ID allows me to import. So this is standard JavaX validation pattern. And this takes like a regular expression. So I could do like a regular expression. I could say this can be Sergio or John. And let me add this annotation also to the method that I am overriding here as well with the name string. And I can do here like now I could take here the name here, right? Instead of world, let's do here like Let's modify the controller to supply a value. So you see the controller is now complaining. I can use path variables as well. So I can do here like something like name. And here have something like name string as a name. Now I have to change my test. I could do here something like hello. I could do here val Yuri builder of hello path Sergio. Or did I use? We put it in uppercase, otherwise the validation will fail. And in the let me extract a name here. And now I can pass here the name as well. Let's modify the HTTP client so that it takes also like a parameter. And I could do here the same way as we did in the controller. I could do here like name. I sometimes like to put here path variable. It's kind of syntax issue at this point because I'm not changing anything, but I like to convey what the parameter is. So I could do here name string. And hopefully the test will be green now. It is not. Correct. So this is something that I wanted to show you. So Kotlin is a bit of a pain for framework developers because for framework developers often, so Kotlin classes are final by default. And for the Sherlock Holmes in the room, you saw that by default, we apply the all open plugin, but sometimes you have to specify it directly. So the way we do is we generate extra bytecode, which is classes that extend your classes and call you to be able to provide AOP at build time. So what the framework is doing, it's seeing that you have a method with a constraint annotation. We have to generate a class that validates this thing basically and calls your method. So we have to be able to call this class. So you're going to have to open this class. On working with Micronaut and Kotlin, one of the things that you're going to see is that you have to relax a little bit the everything final by default in Kotlin. So now the test is passing, but the expectation is be hello world, but hello name. And let's run the test again. So we support validation. You can use all of the standard validation constraints. So add not blank. Well, in Kotlin, you only have to use not null because nullability is more controlled in Kotlin, but you can use not blank, at regex, or you can create your own. For example, we did like in a client project, we had like a form that took like phone numbers, and we created a validation that validated that the phone numbers were like in the phone number specification format, which I am right now not remembering, but essentially like the country codes and the digits were compliant to the requirements. So you can create your own custom annotations and wire them up to the standard validation interpinnings. So that's kind of Micronaut core in a nutshell. So dependency injection, configuration injection, HTTP client, validation, all at build time. In my slides, I wanted to show you something. I wanted to talk to you about so what is GraalVM? GraalVM is a matchmaking heaven for Micronaut. GraalVM is a polyglot I'll polyglot virtual machine from Oracle. The interesting thing is for us Java developers, this like they have a component called native image, and they allow you to generate a native image, a native executable of your application. So it will be like a native executable build for your platform that you are like generating the file. And native executables, they are amazing because they start extremely fast and they consume really low memory. So GraalVM native executables will allow your Micronaut applications to go to places where basically Java applications could not go, such as often serverless or containers where you have really important like low memory consumptions constraints. So our build plugins, they have like tools, both Gradle and Maven, to generate native executables. So let me show that to you. So if I go here to downloads and to our app, I should be able to do, sorry, I should do SDK list Graal Java. So I should be able to install 22.3, so we support the latest. So I want to show you like SDK install Java. I had it installed. So I'm going to install so Graal you can use in Git mode as well. So it's like they support like a JDK released, and inside this there is like the native image component, and our build plugin will basically streamline native image generation for you. Really simple. Before I do that, let me show you something which I didn't show you. Let me run the app because we said that I told you about the constraint, but I never show you the constraint failing. So let me run the app. I forgot. I'm going to run the app. It's going to start in localhost 8080. I'm going to do here curl log -I -b localhost 8080 hello Sergio, right? And I'm going to return like a localhost, sorry, the typo. So you see here 200, okay. Hello, Sergio. And we said we added this add pattern annotation here, and we were expecting like to fail if the name is not Sergio or John. I didn't show you, but let me show you that. So if I enter here like hello world, going to return like a bad request. This JSON that you see right here is in the BND error format. You can plug other formats such as problem JSON by adding an annotation in your application. So let me show that to you in a second. So I am here opening in my other monitor. Micronaut is a modularized framework. I am just touching the surface of what's possible with Micronaut in this talk. You have like many modules for different things. One of the modules that I'm going is problem JSON. I am basically getting the dependency so that I don't do a mistake. So you saw here the error format is a bit ugly for me, but this is BND error is the name of this format. I'm gonna add here problem JSON, and automatically the errors of my applications, they are gonna use problem spec, which for me is my cup of tea, is the one I like. So I'm gonna run it, and when the app starts, downloading the dependency and starting. And there you go. Now it's a content type application problem JSON and problem JSON format. If your organization has the requirement that your errors must be specified in your own format, completely fine. It's really easy to customize that with the error processor API that we have in place. So check it out if those are your requirements. I'm gonna I install. Let me just do the use the GraalVM JDK that I just installed. Let me try to generate the native. I don't know if I have to install native compile. Should be the command. This should generate a native image. Try something. I don't know if I have to install this just in case we need it. I don't know why, but GraalVM doesn't come with native image component by default installed. So generating with our Gradle plugin is just as easy as running native compile. Micronaut, as I told you, doesn't use any reflection internally. So if you are like just using Micronaut things as we are using, GraalVM native image generation is going to be extremely easy. As you will see, it's only a little bit slow. If you are using some transitive dependencies, which all of us use, we have like so my GraalVM it's not that it doesn't work with reflection. That works with reflection, but you have to whitelist your reflection usages. We have done work to basically provide that reflection configuration that GraalVM needs for third-party dependencies that the framework integrates with. But if for whatever reason we cannot provide you can also like provide your own reflection config. We have annotations that will allow you to do that in an easy way. So let's see if the native image generation finishes. If not, I will jump to something else. Generating a native image and doing an online talk is sometimes a risky business, but hopefully we can manage. You can distribute your Micronaut applications as FatJar, as Docker image, as GraalVM native executables, as GraalVM native executables within a Docker image, a FatJar within a Docker image. So we have great integration for Docker as well. And FatJar, if you want to generate a FatJar, absolutely, we support that. You just run Gradle shadow jar, and that will generate a FatJar of your application. Let's see if native executable generation finishes. I'm able to run it. If there are any questions while we wait, please. Okay, the native image finished. It tells me the native image is written to native compile. It's going to have Brighton demo because that's the name of my project. Let me do it like ls minus la Brighton Kotlin. You see that this is like a, we do like, I have to do the human. It's like a 69 megs tailored to macOS. I am running a macOS. This is an x86 iMac Pro, so it should run this thing. Whoa. Let me see if I have their server running also. That's why I didn't manage to start. You saw that it started blazingly fast. It starts at 37 milliseconds, which is quite impressive. And this is the real deal. So I can run a card request against this. If I do like car localhost 8080 Sergio, you see the response came extremely fast. So, and if I stop the native image, you see that the request was being sent against the native image. So native image, extremely fast, extremely low memory consumption, extremely easy to be built with Micronaut. And the last part that I have for you today is I wanted to. So this was really like a MyCode one-on-one demo. So we have integration with reactive libraries in the vein that I told you before. We are reactive library agnostic. You can use RxJava 2, RxJava 3, Project Reactor. Internally, we use Project Reactors in Micro 3. So if you want to use a reactive library, my recommendation is to use Project Reactor with Micronaut. If you want to stick with blocking, you don't have to use reactive libraries at all with when you're working with Micronaut. So that's completely fine. Don't be intimidated. If you want to write reactive applications, you can do that with Micronaut. If you don't want to write reactive applications, that's completely okay, and I understand that as well. Serverless, we support, you can build Micronaut applications to deploy them to Lambda, to Google Cloud Run, to Azure Functions. We are cloud agnostic. We have integration with the four major clouds, with AWS, with Google Cloud, with Azure, with Oracle Cloud. For example, we deployed recently Micro 3.8 Micro Data for Cosmos DB, which is the non-SQL database in the Azure world. So whatever the cloud is, we should be there for you. Runtimes, I have shown you today the default runtime for MyCode, which is Netty, but we support servlet runtimes such as Jetty, Tonka, or Undertow. Or you are working with Lambda, you are not even running like any of these servers. You are like running inside a Lambda function. So we support runtimes, different runtimes. The default one is Netty. Messaging, we support MQTT. We have a MyCode MQTT module. We have a MyCode Kafka module. We have a MyCode RabbitMQ module. We have a MyCode NATS. So if you want to build an application and use messaging, we have a really nice programming module for you. We support database migration tools. We encourage people to use a database migration tools, and we have support for the two major open source database migration tools, such as Flyware or Liquibase. You can use either of these great database migration tools. For persistent, we have a really interesting story in persistent. We have MyCode Data, which I didn't show you today, but MyCode Data is kind of our similar to GORM data services or to Spring data, but everything done at build time. We have different flavors for MyCode Data. We have MyCode Data for JDBC. We have MyCode Data JPA if you want to work with Hibernate. We have MyCode Data for MongoDB. We have MyCode Data for R2DBC. We have MyCode Data for Cosmos DB. So this is the repository pattern. You create an interface. You annotate the interface with at repository, and we implement at build time the SQL queries for you. Really, really powerful, really nice to work with. We have also integration with Redis. We have also integration with Neo4j and with Juke as well. So if you want to use Juke and MyCode, that's fine. We support that. MyCode views. Even the framework is named Micronaut. You can build monoliths and you can build MyCode applications which render on the server side HTML. In fact, that's kind of my cup of tea. We have support for many template rendering engines. So we support ThymeLeaf, JTE, Handlebars, Rocker, Pebble, Soy. And we have even integration with Turbo, which is one of the technologies in the Hotwire umbrella. And we have like using Turbo in a MyCode application, we have some extra notation that will make your life a little bit easier. In terms of security, we have a great module called MyCode Security. We support almost everything that you can imagine. So we support session-based authentication, basic authentication, token-based authentication. We have support for JWT. We have support for LDAP servers. You can have multiple LDAP servers. We have auth2 integration. We have OpenID Connect integration. So you can have, for example, your users in your Micronaut application using signing with Google or signing with Okta or with Keycloak or Cognito. Really powerful and hopefully easy to work with security solution. I saw that we support multiple error handling formats such as BND error problem JSON. If you want to go the the microservices route, we have like a great integration with tracing technologies such as Zipkin, Jaeger. We have support for OpenTelemetry as well. Service discovery with support Consul, Eureka, and many more modules. So we have integration with Kubernetes, we have integration with gRPC, have a module for Micronaut Cache with all the implementations that you can imagine for Micronaut Cache, Hazelcast, Redis, MicroStream. We have we have a great email module. So if you want to use the things such as Mailjet, Amazon Simple Email Service, you can use that with a nice abstraction. We have you can build a CLI application with Picocli. We have support for things such as micrometers. So the framework is much more than what I have shown you today, but hopefully you got the appetite for learning more. My recommendation is, if you want to learn more about the Micronaut framework, just the important bit is that you remember the homepage of the framework is micronaut.io. And in micronaut.io, I'm really proud of this thing that we call Micronaut guides. This is step-by-step tutorials. We have more than 100. Since this is a Kotlin user group, we have, I think we are one of the only frameworks that we have almost all of our tutorials written in Kotlin. So if you want to use Gradle and Kotlin, you go to the matrix, and there you go, and you will see all the sample codes written in Kotlin. And we have all these code snippets. They are coming from real applications. So you will see that there are always like tests in the sample applications, and you can download like a complete solution that will be built. And we have infrastructure in place so that we are able to update these samples to the latest version. So this is all of these applications. They are running the latest samples. All of these projects are built with the latest Micronaut versions. So I don't know. For example, I was showing you like dependency injection, but if you want to use field injection, you have here a guide that shows you how to use field injection. So check Micronaut guides. They are like 30 minutes commitments to do one of these tutorials, and they will help you like getting started with the framework. And then go to the modules, check what is in place for you. We have a lot of user documentation. I think the Micronaut documentation is good. We have like the main documentation for the core of the module, but then we have like configuration reference. All the configuration that you can use is here. This configuration comes from code as well. So there are no typos. The real configuration that is used is generated in the documentation. So check it out. If you like what you see, engage with our Gitter community. Gitter is kind of our Slack or Discourse. And yeah, reach us in social media. In Twitter, we are Micronaut FW. Myself, I am Sergio del Amo. And yeah, that's everything I had for you today.